Okay, so today you're going to learn two lessons, 11.2 and 11.3, which are graphing rational functions. Your homework for tonight is going to be just the 11.2 Math Excel on your online book. Okay, so let's start with 11.2. You need to know how to graph a reciprocal function. So here is the parent reciprocal function. It is y equals 1 over x. So let's go ahead and graph the parent function and answer these questions. And then I'll show you how to do some transformations on this parent function. So in order to graph the parent function, it would be helpful if we make a table of values. So I guess we can start with if x equals -2, y would be equal to 1 over -2, so that's -1/2. And then just keep going. If x equals -1, y would be 1 over -1, so just -1. If x equals -1/2, y would be 1 over -1/2, so that would be actually -2. That's why this is called a reciprocal function. If x equals 0, y would be 1 over 0, which is undefined. So there wouldn't be anything for x equals 0. You can put undefined or NA, not applicable. Okay, keep going. If x equals +1/2, y would be 1 over 1/2, so 2. If x equals 1, y would be 1. If x equals 2, y would be 1/2, and then so on. But we're just going to graph these points. So what you need to know about the reciprocal function is that it has asymptotes. So let me graph those asymptotes. Okay, I forgot to put asymptotes here, but let's go ahead and write asymptotes. Asymptotes is just going to be a line where your graph approaches that asymptote, but it never crosses it or touches it. So the asymptote for this reciprocal function is that x can't equal to 0. So x equals to 0 is an asymptote. Let me graph it. So again, x cannot ever equal to 0 because if it does, then you end up having 1 over 0, which is not possible. So x is equal to 0 is one of the asymptotes. And then because x can't ever equal to 0 here, then another asymptote is going to be that y can never equal to 0, or y equals to 0 is another asymptote. So now the graph, the function that we're gonna graph here, we're gonna graph those dots, and then your graph is gonna get closer and closer to those asymptotes without touching them. So here's how you would do that. Let me start with -2, -1/2. -1, -1. -1/2, -2. Okay, so basically I put three little dots right here, which are the negative ones. But you can, it looks like this. Let me just draw it first. It's gonna look down like that because if x is like -1/3, you would have y would be -3. Or if x equals -1/4, y would be -4. So it keeps going this way. And on the other side, it keeps going that way towards infinity, but it gets closer and closer to 0, but it never touches 0. Like for example, if x equals -8, y would be -1 over 8. So it gets closer and closer. So it just kind of looks like this blue line that I've drawn here, approaching both asymptotes like that, but never crossing them. And then that's going to be the same situation over here on the positive values. If x equals 1, y is 1. If x equals 2, y is 1/2. If x equals 3, y is 1/3. If x equals 4, y is 1/4, and so on. Like if x equals 8, y would be 1/8. So it keeps going like this. Closer and closer to 0, but never touching or reaching 0. Same thing on this way. If x is 1/2, y was 2. If x is like 1/8, y would be 8 over here. But it kind of looks like that. So this is called the reciprocal function. You need to know how these parent points work. And we're only going to graph like 3 parent points on the positive part of the graph, and then 3 parent points on the negative part of the graph. And I'll show you how to graph transformations in a minute. So now that we have the drawing there, let me show you the information about domain and range. So the domain of this reciprocal function is going to be all real numbers except for 0. So there's different ways to write that. You can put like negative infinity to 0, but don't include the 0. Union with 0 to positive infinity. That's one way to write it. Or you could also write it with set notation like this. X such that x doesn't equal to 0. Either one's correct. You can write it however you want to. I think you would see these as like multiple choice questions on your test. So you can just choose either one. Just know that the domain is all real numbers except for 0. The range is going to be the same thing. Yeah?
Is this basically like the restrictions of the...
Now for the range is the same thing. The y values, if you notice the graph, the y values can be anything from negative infinity all the way to positive infinity, except for y can't be 0. So same thing, you can write the range as negative infinity to 0, union 0 to infinity, with the parentheses, which means don't include 0. Or you can just put like the range as a restriction, like you can just put y such that y just doesn't equal to 0. So this restriction just means that y can be anything except for 0. Y cannot equal to 0. The x and y intercept for this graph, it doesn't have any. Since it doesn't touch the x-axis nor the y-axis, there aren't any x-intercepts and there aren't any y-intercepts. And because we do have those domain restriction and range restriction, that's where we have those asymptotes. So the asymptotes would be that x equals to 0 is one of your asymptotes, y equals to 0 is the other asymptote. So you do need to know how to graph the parent function, especially like how to graph these 3 points here, the positive 3 points, so 1, 1, 2, half, half, 2. And then you need to know how to graph the 3 negative points. So -1, -1, negative half, -2, and -2, negative half. And obviously you need to know the asymptotes. So that was just the parent function to get you started. Now you need to understand how to use transformations on this parent function. So this equation here shows you all of the possible transformations. You need to know them all. So I guess let's start with A and D. A and D are vertical transformations. Vertical transformations. They will affect your y values. So for example, A is going to be, if A is negative, like if you end up having like a -1 up there, then that's a reflection over the x-axis, and your y values are gonna become negatives or opposites. Also, if A is a fraction between 0 and 1, so like if you end up having like a 1/2 there or a 1/3 there, that's a vertical compression. Or if A is a number bigger than 1, like 2 or 3 or 5, that will be called a vertical stretch. And again, that's just affecting your y values. D is also a vertical transformation, and that's just a vertical shift. So if over here I had like a +3, that means you would shift your y values up 3. Or if I had like a -6 out here, then you would shift your y values down 6. Next, B and C are horizontal transformations. Horizontal transformations. So those are going to affect your x values. If you do have a negative down here, negative coefficient with your x, that means it's a reflection over the y-axis, so your x values turn into their opposites. And then 1 over b is called the horizontal compression if it's a fraction. And then 1 over b is a horizontal stretch. It's like backwards. So like if you end up having like a 2 down here, like a regular 2, then you would say that is a horizontal compression by 1/2. Or if there is a fraction on the denominator, like a 1/3 fraction right there, then you would be saying that it is a horizontal stretch by 3. I'll show you some examples when we get there. Okay, the last thing you should also know about the transformations of the reciprocal are the asymptotes. So asymptote. The parent function had x equals to 0 and y equals to 0 for the asymptotes, but here are the transformations for any of the asymptotes. X is equal to c is always the vertical asymptote. So if there was a shift horizontally, that's where your asymptote will be. Same thing with the vertical. It used to be y equal to 0 for the parent, but if there is a vertical shift, your asymptote will be y equals to d. So that's very important. Now I'm going to teach you how to graph one of these using all this information that I just talked about. You will be graphing a horizontal, a reciprocal function on your next quiz in Delta Math. And I did make a practice quiz because in Delta Math you have to like put the dots in the right place to graph. So I made you like a little practice quiz before you take the real quiz later on this week, which I'll tell you more information about on Wednesday or our next class. Okay, so now here's how you're supposed to graph these. So by hand, the way you graph this is graph the following. So number 1. So this function has some transformations. I would start by listing the transformations first. You can list them in any order you want. But first of all, there's a +4 right there. So that's a vertical shift up 4. So I'm going to write that down. Vertical shift up 4. And then there is an x minus 2. So that's going to be a c value there. So that is a horizontal shift to the right 2. Because although it says x minus 2, that means to the right 2. So horizontal shift, right 2. And then again, it helps if we start with the asymptotes. I forgot to include those as part of your information, but let's go ahead and write down the asymptotes. So because the function was shifted horizontally and vertically, the asymptotes are no longer 0 and 0. Your asymptotes are not going to be x equals 2 because there was a shift horizontally to the right 2. And then y equals 4 because there was a shift vertically up 4. So that's your new asymptotes. And that's how I start graphing these. I start by graphing the asymptotes and then I can graph the dots. So on your graph or on your graph paper, I guess, you will need graph paper for your next quiz and test. X equals 2. So let me sketch it here. Y equals 4. So those are your new asymptotes. So now what's going to happen is, okay, the way I like to graph these is, now that I've graphed my asymptotes, pretty much all I'm doing is I'm shifting that parent function to the right 2 and up 4. So basically, like, all these little dots from the parent, they're just going to be shifted to the right 2 and up 4. So the way I think of it in my head, like, I guess, here's trying to explain what goes on in my head. But anyway, so the way I think of it is this 2, 4, that's where the asymptotes meet. I just pretend like that's the new origin. Like, I just pretend that's the origin, like 0, 0. And from here, I just graph the parent points. So like in my head, I have the parent points memorized. I know the points are, for the positive function, I know the points are 1, 1, because 1 over 1 is 1. I know 2 comma half, because if x is 2, then 1 over 2 is a half. And then I also know half comma 2, so to the right half and up 2. Because if x is a half on the parent function, if you end up with 1 over a half, that means that y is 2. So, and then I just connect the dots. So one more time, I just pretend that where those asymptotes meet, I just pretend that that's the origin, 0, comma 0, and from there I graph the parent function. So the points for the parent function are 1 half, comma 2, 1, comma 1, and 2, comma half. And those are the positive part of the function. And then on the other side, I'm going to do the same thing. So remember, the other side was the negative part of the function. It's not going to be negative anymore, but for the negative part of the function, the points were negative half, comma, negative 2, negative 1, comma, negative 1, and negative 2, comma, negative half. So that's what I'm going to graph from that new origin that I made up. So again, right here where the asymptotes meet, that's my new origin. I pretend that that's 0, 0. So from there, I'm going to graph negative half, so to the left half, comma, negative 2. From the new origin, I'm going to graph negative 1, so that just means to the left 1, down 1. And then again, the last point of the parent was negative 2, comma, negative half. So from this new origin, I'm just going to go to the left 2, down half. And connect the dots like that. And that's how you graph a reciprocal function that has been shifted. So this one only has shifts, vertical and horizontal. That's how it looks like. Let me show you some information, and then I'll show you how to graph the one with the shift and the stretch. But let's finish number 1. So if you look at your graph and analyze it, you should be able to tell me the domain and range. The domain is also almost all real numbers, except for now, x can be everything except for 2. X cannot equal to 2 because that's where the asymptote is. So we could put negative infinity to 2, union 2 to infinity. So you can write your domain like that. Or you can write it how I did on the answer key. I think on the answer key I just put, for my domain, I put x such that x doesn't equal to 2. But I'm just going to leave it as interval notation here. Same thing for the range. So for the y values, again, the y values are almost everything, negative infinity to positive infinity, except for y can't equal to 4. So again, you can write it in interval notation, negative infinity to 4, union 4 to infinity. Or you can write it in set notation like I have on my answer key. You could put y such that y is not equal to 4. So that just means y can be everything except for 4. So that's my domain and range. The x and y intercepts, now this function does have x and a y intercept because it does cross the x-axis somewhere right here, and then it also crosses the y-axis. It looks like for the y-intercept we can tell what it was because it was one of the points there. It was 0, 3/2. So that can be my y-intercept here, 0, 3.5. If you can't tell what the y-intercept is straight from looking at the graph, like if it's not one of the points, we can still find that y-intercept by plugging in 0 for x. So if you put 1 over 0 minus 2 plus 4, this is just negative 1/2 plus 4. So it is positive 3.5. So that's what I put here. You can put 7/2 if you want to as a fraction, 7/2. So that would be my y-intercept. You find it by plugging in 0 for x. Now the x-intercept is just going to be the other way. For the x-intercept, you have to plug in 0 for y. So again, I don't know, I can't tell exactly what the x-intercept is there because there wasn't an actual point, but we can find the x-intercept by plugging 0 for y and solving the equation. So let me do that. Let me plug in 0 equals 1 over x minus 2 plus 4. So let's solve for y. I'm sorry, let's solve for x now. So one way to solve for x is bring the plus 4 over to the left as a minus 4 equals 1 over x minus 2. Now what I would do to solve for x is I would cross multiply this. So pretend that negative 4 is a fraction. So pretend you have negative 4 over 1 equals 1 over x minus 2. So if you cross multiply, negative 4 times x is negative 4x. Negative 4 times negative 2 is positive 8. Equals 1 times 1 is just 1. Now that's just a simple linear equation, so solve it for x. Negative 4x equals negative 7. It looks like x equals positive 7/4. So that's my x-intercept. So, number 1. That's how you graph the function. Make sure you know how to graph the function, obviously. Make sure you know how to answer domain and range, how to find the asymptotes, how to list the transformations, and then obviously, like I just did, make sure you know how to find the x and the y-intercepts. I'll pause for questions, and then I'll try and show you number 2. Okay, so number 2. Number 2 is, again, the first thing I would do is list the transformation so you can see what happens to the graph, and then you can graph it to find the information. So number 2, there's definitely a shift, vertical shift down 3 because of this minus 3. There's also a shift horizontally, again to the right 2 because it says x minus 2. And then finally, there is a 2 on the numerator. That's considered an A value because that's where the A value is here on the numerator. So that A value is considered a vertical stretch because it's more than 1. So I'm going to say vertical stretch by 2. So remember, a vertical stretch by 2 is going to stretch the y values by times 2. Now that I found the transformations, it helps to do the asymptotes. The asymptotes for number 2 would be x equals 2 again, and y equals negative 3. So I would start graphing the function by graphing the asymptotes. X is equal to 2 is the asymptote. So that means that your domain restriction is going to be that x can't equal to 2. Y equals negative 3 down here. So for your range, it's going to be all real numbers except for negative 3. And you can write that in interval or set notation. So the way I do it in my head is I pretend that right here where those asymptotes meet, I pretend that that's the origin, 0, 0. If my way of graphing doesn't make sense to you, then you could always just start plugging in x values here into the function and making your own little table of values so that you can see what the points would be. But the way I do it is I pretend that this is 0, 0. If there are no stretches at all, then I would just graph the parent points. Remember the parent points that are 1, 1, 2, half, and the half, 2. That's what I would graph if there was no stretches or shrinks. However, right now there is a 2 there, so that's a vertical stretch by 2. So then here's how I do it. Instead of graphing the point at 1, 1, I'm going to graph the point at 1, 2. So to the right 1, up 2. I went up 2 because I vertically stretched my parent point by 2. The other parent point is supposed to be at 2 comma half, so like to the right 2 and up half. But this time I'm going to go to the right 2, and instead of going up half, I'm going to go up 1 because half times 2 is 1. I'm stretching the y values by 2. And then the half point over here that I left out is supposed to be, for the parent, it's supposed to be at 1 half comma 2, so to the right half and up 2. But this time I'm going to go to the right half and up 4. Because all I'm doing is I'm stretching the y values of the parent function by 2. Okay, if that didn't make any sense, then just make your own little table of values here. Pick your own x's, pick your own y's, and just make a table of values for the right side of the graph and for the left side of the graph. For the left side of the graph, I'm just going to do the same thing in my head. I'm going to take the parent point. So I guess let me start with the negative half, negative 2. But this time I'm going to stretch that y value by 2. So it's going to be at negative half comma negative 4. 1, 2, 3, 4. So go to the left half, down 4. The next one is supposed to be negative 1 comma negative 1. But this time it's going to go to the left 1, down 2. And then the last point is supposed to be to the left 2, down a half. But this time I'm going to go down 1. And it looks like that. And again, that is how I graph reciprocal functions with transformations. You can always just make your own table of values and figure out where the points would be. The domain and the range, you can just list them. Any notation you want. You can say, I'm going to do set notation this time. Domain is all real numbers except for 2. So x cannot equal to 2. The range is all real numbers except for negative 3. So y cannot equal to negative 3. To find the x and the y-intercept, you would just do what I did on number 1. For the x-intercept, plug in 0 for y and solve this equation for x. I don't have time to show you because I still have to teach another lesson, but I'm going to copy the answer key and hope that it is correct, so 8/3. For the y-intercept, you plug in 0 for x and you solve for y. So we're just copying the answer key and it says it's negative 4. And again, that's how you graph those reciprocal functions and find the information. Okay. The last one, that one I already gave you all the information here to try to help you graph it. So we're just going to quickly try to graph this. It already has the transformations, but again, I forgot the asymptotes. So number 3, the asymptotes are going to be a y equals 2 because of this plus 2. And x equals 1 because of this x minus 1. So x equals 1, let's do. All right. So then, like I was telling you, the way I graph them, I just look at the parent function. And the parent function is supposed to be like 1 comma 1, 2 comma half, and half comma 2. But this has it has a vertical stretch of 3, which I forgot to write on here. I think I fixed it on my answer key online on the title, but that should be a vertical stretch by 3. And then there is a negative in front of this fraction, so that's a reflection over the x-axis when it's a negative in front of the fraction like that. Okay, so the way I would apply this vertical stretch by 3 and this reflection over the x-axis is just by changing the parent points and multiplying the y value by negative 3. So my parent points here, instead of graphing, for example, instead of graphing half comma 2, I'm going to graph half comma 2 times negative 3 is negative 6, so down 6. 1, 2, 3, 4, 5, 6. It would be right here. Instead of graphing the 1 comma 1, I'm going to graph 1 comma negative 2. Nope. 1 comma negative 3. So the right one, down 3. Right here. And then instead of graphing the to the right 2 up half, I'm going to go to the right 2 and half times negative 3 is negative 1/2. So right here. It looks like that. The other half is going to just be the other part of it. So my other part was negative half to the left half up 6. So 3, 4, 5, 6 is going to end up right here. Negative 1 up 3. 1, 2, 3. And then negative 2 up 3/2, so 1.5 right here. So there we go. That's called graphing reciprocal functions. For homework tonight, you need to practice this lesson. It's called 11.2, graphing reciprocal functions. So please practice that so you know how to graph it. And now I'll pause for questions and then we'll do our second lesson. Okay, so now I'm going to teach you the 11.3 lesson. That one's going to require like, 2 days worth. So we're going to start it right now. This is 11.3. And then we're going to continue it again on our next class. So I guess Wednesday or next time I see you, we're going to finish 11.3 with some more examples. But 11.3. That's going to be like majority of your Delta Math quiz. You'll have 11.3 on it. This one is called graphing rational functions, like something like number 4 here. And it's just a lot of information that you can have to like memorize in order to graph these correctly. So here's some information, I guess, that you're gonna have to memorize and understand. We're gonna just go straight to like working these out. So number 4. When you have a rational function, such as this one, y equals 2 over x minus 2 times x plus 5 squared, here's how you find the x-intercepts. I'm just going to read you here. X-intercept. You set the numerator equal to 0 and solve for x. If there is no x in the numerator, then that means that there's no x-intercepts. So again, like if I set my numerator, which is 2 equal to 0, that's clearly not the same, so this is going to be no x-intercepts, none. So one more time. To find the x-intercepts, set the numerator equal to 0 and solve for x. That is going to give you your x-intercepts. If there is no x in the numerator, then it means that there are no x-intercepts. So that was step 1. Done. Step 2, the y-intercept is the same thing as it's always been. To find the y-intercept, plug in 0 for x and solve for y. So let me do that on my equation here. Let me erase this. So let's plug in 0 for y. So sorry, to find the y-intercept, plug in 0 for y and solve for x. Just kidding. I don't know what I'm talking about. It's okay, the video is still good. To solve the y-intercept, plug in 0 for x and solve for y. So let me do that. Y equals 2 over 0 minus 2. 0 plus 5 squared. It takes too long to edit a video, so we're just going to go with the mistakes and fix them. But anyway, so one more time. To find the y-intercept, plug in 0 for x and solve for y, and that will give you your y-intercept. So let's simplify this. This is going to be 2 over negative 2 times 25. So that looks like it's just going to be 0, -1 over 25. Because the 2's cancel and you're just left with the negative. So -1 over 25 is the y-intercept. So that is step 2. Step 1. Step 2. Okay, step 3. Your rational functions have vertical asymptotes and horizontal asymptotes. Let's go ahead and talk about the vertical asymptotes. So those are the ones that go up and down. Vertical asymptotes, in order to find those, you're going to set the denominator equal to 0 and solve for x. Vertical asymptotes never get crossed. So let's do that. Let's go ahead and set the denominator equal to 0 and solve for x to find my vertical asymptotes. So my denominator, one of my denominator factors is x minus 2. So I'm going to put x minus 2 equals to 0, and that's going to give me my vertical asymptote. And then the other one is x plus 5 squared. I'm just going to put x plus 5 equals to 0. The square does matter, and I'll show you how in a minute, but for now you can just put x plus 5 is equal to 0. So then that means that my vertical asymptotes are x is equal to 2 and x is equal to -5. So I will graph those asymptotes here in a second, and then I'll explain to you what this asymptote behavior means. For now, let's just write them down and then keep going with our next step. Those were the vertical asymptotes. Now you need to do the horizontal asymptotes. Horizontal asymptotes go left and right. Here's how you find those. If the degree of the numerator, degree means like the exponent of your variable. That's the degree you look of a polynomial. So if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y is equal to 0. It is possible to cross a horizontal asymptote. So on our example number 2 here, on the numerator, the degree is 0 because there isn't an x, or basically there is an x. It's like x to the 0 power, which is just a 1. So on the numerator, the degree is 0. On the denominator, if I were to expand this, technically on the denominator, the degree would be 3 because you have an x times an x squared, so that's a cubic. So because the degree of the numerator is less than the degree of the denominator, my horizontal asymptote, or aka the HA, is y equals to 0. So for today's examples, they're all y equals to 0. On Wednesday, we'll do the other ones. So horizontal asymptote, y equals to 0. Now we're going to graph this and figure out where the HA gets crossed, if it does, and how does this whole thing work. So the first thing I do when graphing these is I graph the asymptotes, just like I did for the reciprocal function. So let's try to graph all my asymptotes. X equals 2, x equals -5, graph them. This is x equals 2. X equals -5. Right here. Y equals 0 is the horizontal one. So I would start by graphing all of the asymptotes first. Next, what I would graph would be the x and y intercepts. This function did not have any x-intercept, so that means that the function never crossed the x-axis. And therefore here, the horizontal asymptote, which is the x-axis, y equals 0, it never gets crossed, none. Because remember over here there was no x-intercept, so then therefore it doesn't get crossed ever for this specific scenario. So don't graph any x-intercepts because there weren't any. Next, go ahead and graph the y-intercept. I'm going to rescale this y-axis because it's really hard to graph 0, -1/25. So I'm just going to pretend that this is -1/25 right here. So I'm just rescaling it. And now we start graphing this function. Okay, so one way that I start graphing these functions is I start with the points that I know on the graph. So the only point I know on the graph is the 0, negative 125. So since that's the only point that I know, that's where I'm going to start. So here is just going to be a sketch, so yours doesn't have to be exactly like mine, but here's what the sketch would look like for this. Starting at this point, you're going to draw a graph that approaches the asymptotes. And for example, this graph is going to approach my asymptote by x equals 2 by going down towards it. I know that it has to go down because it can't go up for this scenario, because if it were to go up, that means that you would have crossed the x-axis. But remember, there are no x-intercepts. So then you know you can't draw it going up. It has to be going down. Okay, same thing for the other asymptote. Your graph needs to approach this other asymptote at x equals negative 5. So again, you need to go towards it. And then again, you can't make it go up, because if you make it go up, it means that it would have crossed the x-axis somewhere here at negative, I don't know, negative something. But there are no x-intercepts, so you can't make your graph go up, so you're going to have to make it come back down again. And again, that's just a sketch. So that's a part of my graph. Now, my graph had 2 vertical asymptotes. So that means that this graph is divided into 3 sections, like the right part of the graph, the middle part, which I just graphed, and then there's a left part of the graph. So now here's how you find the right and left part of the graph. You can find it by for example, we can plug in a point. Like we want to know what is the graph over here when x is more than 2. So like let's say when x is 3 or when x is 4. You can plug in x equals 3 here and there to figure out what your y value would be. Or, here's what I know. I know that on this side of the graph is going to look like, first of all, let me just sketch it for you. It's going to look like this. And let me tell you why. So I know that the graph is going to look like that, even though I didn't actually plug in x equals 3 here to figure it out. You can if you want to. But the reason why the graph does look like this on this side is because of this thing called the asymptote behavior. So let me read it to you and try to explain it to you. Asymptote behaviors. So that's calling the vertical asymptotes. When your vertical asymptote has an odd degree, so for example, x minus 2 to the first, the graph approaches your asymptote in opposite directions. So opposite directions means here's a vertical asymptote. Part of my graph is going up at the asymptote, and the other part of the graph is going down at the asymptote. That's called opposite directions. The graph is going to do the opposite direction if your vertical asymptote, which in this case is x minus 2, if it is being raised to an odd power like 1. So like in this scenario here, x minus 2 was being raised to an odd power. So that means that your graph needs to go in opposite directions at x equals 2, which is the asymptote. You already know that part of the graph was going down because I told you so before. So now the other part needs to be going up. That's called opposite directions. Now on this other side of your graph just needs to get closer and closer to the other asymptote of y equals 0. That's just the horizontal asymptote. So let's try to explain it again. So let's do it again with these vertical asymptotes, and let's talk about the second one. So vertical asymptotes. When the even degree. So when your vertical asymptote has an even degree, your graph is going to approach the asymptote in the same direction. Okay, same direction just means, here's an example. I have an asymptote there. Part of the graph is going up at that asymptote, and the other part of the graph is also going up. That's called same direction. That's going to happen if your vertical asymptote is being raised to an even power, such as x plus 5 squared. X plus 5 is being raised to an even power. So that means that this asymptote here at x equals -5 has an even degree. So your graph should be going in the same direction at the x equals to -5. So let me go find x equals -5. There it is. So then I know that this graph is going to be going down as well because the middle part was already going down. And then the other part of it, it just goes closer to that. And that's how you graph a rational function. They're super complicated, and the first time you're like, what is she doing? And that's okay, you just need to practice it. So we're going to do one more example before you leave, but on Wednesday, we're going to spend the whole hour just doing these again over and over until you understand how to do them. So I guess let's just try it again one more time with another example, number 5 here. Let me take you very quickly through the information. Step 1, find the x-intercepts. To find the x-intercepts, you set the numerator equal to 0 and solve for x. So I'm going to do x plus 1 equals to 0. So that means that the x-intercept is -1, 0. And now keep going. Y-intercept. You plug in 0 for x and you solve for y. So plug in 0 for x, solve for y. It looks like the y-intercept is 0, -1/6. Vertical asymptote. For the vertical asymptote, you need to set the denominator equal to 0 and solve for x. Okay, this time, here's my denominator. We're supposed to factor that because we want to find the factors. So let's just go ahead and factor x squared plus x minus 6. Alright, so my denominator is x plus 2 and x plus 3. So again, you just set each of those equal to 0 to find your vertical asymptote. 2. And this is wrong, and nobody said anything, because it's just supposed to be x squared plus x minus 6. So first period, I'm disappointed with you. It should have been a -6 right here. And therefore, which one's negative? This one's a minus. So it should have been x minus 2 times x plus 3. So then that means that my vertical asymptote is going to be x equals positive 2 and x equals -3. Or maybe I'm just going too fast. So now that I fixed my mistake, I correctly found the vertical asymptotes by setting the denominator equal to 0, and you set each factor equal to 0 so that you can find your vertical asymptotes of x equals positive 2, x equals -3. Horizontal asymptote, for today, they're all going to be y equals to 0, but that's because when the numerator has a degree that is less than the degree of the denominator, it's always y equals to 0. So my numerator here has an x to the first. The denominator has an x to the second. So 1 is less than 2, and therefore the numerator has a degree that is less than the degree of the denominator. So y equals to 0. Now I would sketch everything very quickly. Let's sketch it. Okay, I would sketch the asymptotes first, so x equals 2. X equals -3. Y equals 0. After I sketch the asymptotes, I go ahead and sketch any of the points that I know, like the x and y intercepts. So this time there is an x-intercept at -1, 0. So let me sketch it right there. And because there is an x-intercept at -1, 0, that means that this horizontal asymptote is getting crossed, and it's getting crossed at that -1, 0. That always matches your intercept here. Okay, I can still do this. The y-intercept is 0, -1/6. again, I would just rescale the y-axis so that you don't try to squeeze the negative 1/6. So let me just pretend that this is negative 1/6. Yep. And now let me tell you how I know, if you gotta go, you gotta go, but let me just finish this because I started class a little late, so let me just finish my video here. So the way I would connect this is I'm gonna connect those 2 points and start graphing the graph towards the asymptote. So first of all, let me just connect these 2 dots right here. Okay. After I connect the x-intercept to this y-intercept here, from the y-intercept, your graph needs to approach the asymptote of x equals 2. And the only way that it can approach it is by going down. It can't approach it going up, because if you try to make it go up, then you would cross the x-axis again over here at the positive something, but there isn't any other x-intercepts. So then it has to go down. The other graph over here is just going to cross and go go up. I'll have to show you why on Wednesday, but it's going to just, trust me, it's going to go up. And then finally, to finish this, again, this graph has 3 parts, the right, the middle, and the left. On the right part, I know that on the right part, the graph is going to go in opposite directions because x minus 2 for the denominator, that was just being raised to the first power. So that means that your graph has to go in opposite directions at the asymptote, x equals 2. The other half just goes towards the horizontal asymptote like that. And same thing with the left half over here. On this side, my graph is already going up, which I'll tell you why on Wednesday, but it's already going up. So then on this side, it's got to go down because, again, x plus 3 is only being raised to the first power. So when you have an odd degree, your graph needs to go in opposite directions at the asymptote of x equals negative 3. So it needs to go down. And then the other part just goes towards it. Okay, so that was a lot. What I'm going to do is I'm going to finish going over example 6 and 7 by myself on the video. You can come back and watch it